so some of the main points I wanted y'all to get were the parts of the atom, the location, the charge, and what properties it's responsible for. So for the proton, what charge is a proton?
Positive.
All right, protons are positively charged particles. Where are they located? Okay. So it's located in the nucleus. And what does it represent for an atom? The number of protons represents what? Christian, can you open the door? Thank you, sir. So it represents the atomic number. So that's the proton. You can just leave it on the counter. I have your test graded also. So that's the proton. The next one is going to be neutron. What charge is a neutron? Okay, so it is neutral. Where is it located? In the nucleus. Good job. And to be perfectly honest, the neutron doesn't represent anything specifically about an atom. However, it contributes to the mass of an atom. And so we'll get to that in a little bit. But the mass of an atom has to do with the protons and the neutrons. All right, moving on to the next one. So Axel, you just got here, but you can look on someone else's paper because I'm recording this. So the third one is the electron. This is the last subatomic particle that we're going to discuss. By the way, there are other subatomic particles. They're just not in our standards, but there's, if y'all have heard of quarks, leptons, neutrinos, positrons, like there's all kinds of little other things besides these, but these are the main components of an atom. Okay? So the electron, what charge is an electron? Negative, so it's a negative charged particle. Where is it located? And that is called the electron cloud. Which is definitely not the nucleus. And electrons, we're going to have a whole unit devoted to electrons. They're super, super important. They determine all kinds of chemical properties, some physical properties, but the chemical properties, how these things react, whether they're magnetic or not, whether they conduct electricity or not, all kinds of things. So, the next one is isotope. I'll scroll back down. All right, so number 4 is isotope. This would have been from the very last simulation that y'all did. And an isotope, you want to write down exactly what I write and then study this because this definition will be on the test. So an isotope is like variations of the same element they have different numbers of, does anybody know what's different about isotopes? The masses are different. They have different masses, and what contributes to the different masses, I'm just going to abbreviate this, different numbers of N for neutrons, but the same number, if it's the same element, it's the same number of protons. All right? So I'm going to give you an example of this, because you just might see a question like this on a test coming up. So for example, which two are isotopes? Here's a couple of examples. C14, N14, C12. So which two are isotopes? Look at the definition. Which two would you choose? Yes, good job. C14 and C12, because they're both carbon. The number after the dash is its mass. So the average mass for carbon is 12. That's the most common isotope. There are, out of all of the carbon atoms out there in nature, there are 99.9% of all of those atoms are carbon, 12. The other atoms are carbon with a mass of 13 and carbon with a mass of 14. But there's very few of those, but they contribute to the overall weighted average. Nitrogen, that can't be it because it's not the same element. It has the same mass, but it's not the same element. Okay, so that's what an isotope is. All right, moving on to the mass number. So the mass number is something that hopefully you guys understood after you did the simulation. I'm going to go ahead and start scrolling up. Okay. So the mass number, also known as the atomic mass. Whoops. And I was thinking atomic, so I got a little excited here, starting to write down more than I needed to. So the mass number is equal to the protons plus the neutrons. Protons and neutrons are both located where? Yeah. So basically, they're located in the nucleus. So the mass of an atom is just the mass of the nucleus. And guess what? The nucleus of an atom is super, super dense. That means everything is cram-packed together. And the interesting thing about that is, with them being so crammed together, you've got a lot in that little space. If the atom was the size of a football field from end zone to end zone, okay, so 100 yards, guess how tiny that nucleus would be if the atom itself took up the size of an entire football field. Guess how tiny that nucleus would be, everything that's in there. It'd be the size of like a nickel, you guys, a nickel. If somebody were to drop a nickel on the 50-yard line and you're sitting up in the bleachers, would you be able to see it? No. Imagine how crammed the nucleus is. So there are some things about the stability of an atom that we're going to discuss in a minute also. But that's the mass number. Know that it is a decimal number on the periodic table. And I'm just going to write P table for periodic table because I'm trying to condense this. Okay? And then the next thing we're going to talk about is atomic number. Whoa. And I just scrolled and I don't think I need to do that yet. So atomic number. So what is the atomic number equal to? Anybody? It's equal to the number of protons. This is how you identify an element. An element's identity is based on its atomic number or the number of protons. And the other thing I need to tell you about this is that when we have a neutral atom, what would the number of protons also equal? Would it be neutrons or electrons? It would be electrons, okay? So if you have a neutral atom, they're going to have equal numbers of protons and electrons. Remember, electrons are negative, protons are positive, so if the atom has no charge, then protons and electrons are equal. Okay? So we just have two more things we're going to write down. We're going to talk about the nucleus. So the nucleus is located in the center of an atom. It contains protons and neutrons. It is very dense. And what charge are protons again? Positive. What charge are neutrons?
Neutral.
Yep, neutral. So the nucleus has a positive charge. So the nucleus is actually what attracts those electrons that are orbiting the nucleus. Nucleus is what's holding the electrons and keeping them from like flying off. Okay? But you know how I told you that nucleus is really dense and everything is like crammed in there? What in the world did y'all see in your simulation that sometimes when you added a whole bunch of stuff to the nucleus, it started shaking and it said it was not stable? Do you remember seeing that in the simulation? So there's an optimal ratio of protons to neutrons to maintain an atom's stability. So we're going to write this down. So neutrons are what keeps an atom stable. So if protons determine the atom's identity, they're positive. Electrons are negative, and they are kind of orbiting. They determine the chemical makeup of an atom, how reactive it is, its chemical properties. The neutrons, their main purpose is to just keep those protons from touching. If you had something positive and something else positive, and they were crammed together and they were touching, what's going to happen? Are they going to attract or repel? They're going to repel, and that's not stable. Protons would start flying from the nucleus, and then you've got a nuclear reaction. There are some radioactive elements, aren't there? But that doesn't happen until atom number or atomic number 83 and up, because that's when it hits that point where it's like, you know what? Now there's too much stuff in the nucleus. So the neutrons, I'm going to say the neutrons keep the protons from touching. And we need to know this for an example we're going to do where we have to create an atom with a certain stability. So stable atoms can have equal protons and neutrons. Or what do you think you can have more of, protons or neutrons, to make the atom stable? Okay, you can have more neutrons than protons, and you're going to have a stable atom. Now, let me just say, in the simulation, you're going to see some different special cases, but for all purposes of you guys learning about this and on the test, we're going to say they can have equal number of protons and neutrons. So if you have a mass of like 12, you'll have 6 protons and 6 neutrons, make it even. Or you could have some more neutrons than protons. So let's just say we had a mass of 11, not 12. Then it's an odd number. You're going to have maybe 6 of the neutrons and only 5 protons, and not the other way around. Does that make sense? Okay. This will make a little bit more sense once we get an example. And then the last one's the electron cloud. So obviously, what's located in the electron cloud? Okay, so it is where electrons are located. Electrons, by the way, have virtually 0 mass. It's so negligible now because it's matter. It has a mass, it takes up space, but electrons are about 2,000 times lighter than protons or neutrons. The electron cloud is where most of those are just taking up space, orbiting all the time. Now remember, electrons don't contribute to the